Hello, so today we are going to be talking about how to solve quadratic equations by square root. So first of all, we're going to notice that we have an x squared and a constant, right? We do not have the x term, otherwise we would be trying to use other methods like factoring or quadratic formula. So what we are going to do is first, since we are solved for 0, we are going to try and isolate x squared. We can do that by adding 25 to both sides, and we wind up with x squared equals 25. Now, the inverse operation of x squared is to take the square root. So we will take the square root of both sides, and we are left with x equals 5. However, it's not just a 5, because if we plug in 5 for right here, we'll get 5 squared is 25. But what about negative 5? So this comes from the idea that we can have 5 be the answer or a negative 5 as well. Since every time we square a number, we wind up with a positive, we wind up with 2 answers. So that's why we have to include this plus or minus option every time we take the square root of a number. All right? So let's take a look at the next example. So for this, we are once again going to be adding 8 to both sides, and we're left with 2x squared equals 8. So now x squared has a 2 in front as a coefficient, so I will divide by 2 to get 4. We have to take the square root of both sides again, and so we'll be left with x equals, again, the square root of 4 is 2, but we're going to have the plus or minus version. All right, so let's take a look at the next 2 examples. So here we are already with an x squared term on the left and a number on the right. So you can solve for 0 first, but then you're going to wind up just adding the 27 back again. So you can leave it as is. This actually did our first step for us, because you'll notice we always wind up with x squared equals a number in this strategy. So we're kind of already halfway there. So in this example, I'll divide by 3 to get x squared equals 9. And then we'll take the square root of both sides to get x equals, don't forget that plus or minus, and then the square root of 9 is 3. So these are our solutions, 3, positive 3, and negative 3. So now let's take a look at the next example. We're going to add 30 as normal to both sides to isolate x squared. Now you have to divide by 5 to continue isolating x squared. And you'll notice we get 6. So our last step is to take the square root of both sides. However, we do not know the square root of 6. It's actually an irrational number. So we're going to just leave our radical as radical 6. Now, if we had a radical like radical 20, we could simplify it further. But for right now, we're just going to leave it as the square root of 6 because it can no longer be simplified. Okay. Finally, here are our last 2 examples. For this one, we're going to divide by 16 on both sides, but you'll notice that we can't divide 49 and 16 evenly, so we're going to leave it as a fraction. Now we're going to take the square root of both sides, and x is going to be the positive and negative version, or plus or minus, of the square root of 49 over 16. So you can leave it this way, but a more simpler version would be to take the square root of 49 and the square root of 16, since we can identify them. Like if we had the 6 on top, we would leave it. But since we can find the square root of 49, that gets us a 7, and the square root of 16 gets us a 4, we have plus or minus 7 over 4. And our last question, if we subtract 20 from both sides, we wind up with 4x squared equals negative 20, and divide by 4, we wind up with x squared equals negative 5. Take the square root. Well, hey, wait a minute. The square root of negative 5 is actually an imaginary number. We do not allow the square root of negative numbers in the real number system. Later on, we'll wind up with i's and imaginaries and so on. But for right now, all you need to know is when you have the square root of a negative number, you actually have unreal solutions. So you can write it as unreal solutions, or you can write that x does not have any real number solutions. All right, well, I hope you enjoyed. Thanks for watching A Heisey Creation. Have a good day. Bye-bye.